Yeah, to continue with the morning class. So I was discussing about this LT time frequency grid, right? Uh, I hope people have understood this. What is this time frequency grid? Of course, maybe we take x-axis is time and y-axis is frequency. So you have to understand in that way. Okay, so this figure need to be rotated. Okay, is that fine? X-axis is time and y-axis is frequency. As I said, okay, is it possible from your end to say what is resource block and what is resource element? Yes, any one of you can you say what is resource block? Yes, I am asking you people only. Is it possible to say what you mean by resource block? Yes, looking at this diagram, you can't say what is resource block. Resource block.
So the
Uh,
elements, the resource elements that will be like those 12 into those seven, those subcarriers. So like those 12 subframes into those seven make up like 84 resource elements, and this resource block consists of all these resource elements in it.
okay. So to put that sentence in a slightly formal way, what I can say is uh, to define what is a resource block. Okay, in LTE, the mobile units, okay, are allocated group of sub carriers. I repeat once again, in LTE, mobile units are allocated group of sub carriers over time and frequency. Okay, so this is what time, right? OFDM symbol I say, right? It is a time, 0.5 milliseconds. And these are the sub carriers, 12 sub carriers with 0.5 millisecond. So this much resource, that is frequency and time, will be allocated to one particular user. So that is known as the resource block. Hope I am clear.
Yes, sir.
Yeah. So what I said is in LTE, mobile units are allocated group of sub carriers over time and frequency. Okay, that one is known as the resource block. So the size of this resource block, okay, will be chosen such that the trade-off between the granularity and overhead is met. Okay, to balance the trade-off between granularity and overhead, uh, we are selecting the size of the resource block, that is 12 subcarriers and 7 OFDM symbols, so which is equal to 0.5 milliseconds, right? So totally there will be 84 resource elements will be there. Okay, yeah, uh, right. So I what I said is 12 subcarriers with 7 OFDM symbols. So this is one resource block will be allocated in the downlink to the user equipment. Okay. So with that I said 84 resource elements, and these resources, okay, are allocated to the users in units of this resource block. So that is why here in the right side I have written resource block 0, resource block 1, resource block 2, and so on. Okay, so uh, as I said, the resources are allocated to users in units of resource blocks over subframe. Over subframe means here one subframe you have two time slots, right? I told about one slot. So like that, two time slots, two slots, that is slot 0 and slot 1, what I can say is one subframe, right? So resources are allocated to users in units of resource blocks over a subframe, right? So which is equal to what? 12 subcarriers and 7 that is 7 OFDM symbols. So like that in one subframe, totally 14 OFDM symbols will be there. So 14 into 12. So which amounts to 168 resource elements. Okay, 168 resource elements. Means what I wanted to say here is here time slot in LTE. I said it is about what, zero point 0.5 milliseconds, right? The two consecutive time slots, right, uh, will be makes a subframe, right? Hope I am clear what I am saying. One slot means one time slot means zero point 0.5 milliseconds, which consists of 7 OFDM symbols. So two slots means there will be 14 OFDM symbols. Okay, two slots is equal to one subframe. Like that, how many subframes are there? I said in case of LTE frame structure, 10 subframes will be there. The duration of one subframe is 1 millisecond. Okay, in one subframe, there are 14 OFDM symbols and there will be 12 subcarriers. So 12 into 14 leads to 168 resource elements that we call as one physical resource block. Okay, that is known as PRB. Okay, so here time is there and frequency is there, right? So it depends what type of QAM order we select, or even QPSK also. If it is QPSK, only we are transmitting 2 bits per frequency, right? Means only 4 subcarriers will be used. Okay, if it is QAM, again that depends on the value of modulation order. Okay, if I am using 4 QAM, then 2 power 4, which is equal to 16, right? Means I will be transmitting 4 bits for one particular carrier subcarrier frequency, like that. Okay, so I will come back to this again to discuss about in detail about this frame structure and how the resource allocation is done in case of LTE in the upcoming slides, maybe in the further classes. Okay, so just it is here I've given brief introduction about this time frequency grid. Okay, so with that, let me go to the next this one, that is allocation, notification, and uplink feedback. Okay, so let me spend some amount of time here. So which is also very important. Maybe you will be having so many doubts in this. Means the moment you switch on your mobile, how your mobile will be knowing that what resource block it should use, right? Hope you're understanding what I'm saying. Yes, my dear students, I'm asking you people only.
Yes, sir.
Yeah, you may be wondering what frequency or what resource block your mobile should use. Means how your mobile will come to know that, okay, so and so resource block is available for me. Can I use that? Right. So to understand all that thing, so let me see how that information will be passed on to the mobile through what channel, and how the mobile will come to know that, okay, so and so resource block is available and you can utilize that, right? Fine. So in order for each mobile station to know which subcarriers to use in downlink reception and as well as uplink transmission. Okay. So in a downlink reception and uplink transmission. So two things, right? So how does the mobile station, that is user equipment, will be knowing that which subcarriers to use in downlink and uplink transmission, right? So what I said, the base station will be broadcasting that information to the pool of active users in that cell. Okay, let us assume that there is one cell in that maybe hundreds of users will be there. Okay, so the base station will be broadcasting the information about the number of subcarriers available for using to the users. Okay, means that is that too for active users. Okay, not for all users. Whoever is active, for them it will be intimating the information Active users means when their phone is on, obviously will be active. When they try to call, then they're searching for channels, right? So for active users, the base station will be broadcasting that particular information. So over what channel, right? So for that, there is a channel called physical downlink control channel. Okay, in short, we say it is PDCCH, physical downlink control channel. So this physical downlink control channel will be specifying these information. So let me say what is that information is, right? So first one is the downlink resource block allocation. Okay, I repeat once again, the broadcast station will be broadcasting the information about what subcarriers to be used by the mobile station in the downlink and as well as uplink. Okay, I said that information will be carried out by the physical downlink control channel. In short, we say it is PDCCH. Okay, so this PDCCH will be carrying information about the downlink resource block allocation, uplink resource block allocation, then QAM constellation. Okay, I hope you understand what is QAM constellation. Means the QAM modulation order, whether it is 4, 16, 32, 64, like that. Okay, to use per resource block. Okay, what is the QAM constellation to be used per resource block, and as well as it indicates type and rate of coding. Okay, what type of code you are using, that is whether convolutional, I said no, some codes, right? And it's a type of the coding, and as well as its rate also, whether it is 1 by 3, 2 by 3, and so on, to use per resource block. Okay, so these four information will be broadcasted by the base station to the user equipment over this channel. What is that channel is physical downlink control channel. Okay, and this physical downlink control channel will be occupying first 1 to 2 slots of every subframe. Okay, PDCCS will be occupying first 1 to 2 slots of the uh, in a frame. I said subframe, right? In that again slots will be there. So first 1 2 slots, 1 2 symbols will be having that information about this. Is that fine? Hope now it is clear to certain extent what I said. I said how the mobile station will be knowing what subcarriers, right, it should use for its downlink reception and as well as uplink transmission, right? I said the base station in LTE we call that as E node B. So it will be broadcasting that information to the user equipments over the physical downlink control channel, that is PDCCH. So what it will carry? It will carry information about the downlink resource block allocation, uplink resource block allocation, QAM constellation to use per resource block, then type and rate of coding to use per resource block. So this four information will be there in the PDCCH. Okay. So once the user is able to decode this physical downlink control channel, then it will be knowing exactly or precisely where to receive, that is in the downlink, or where to transmit, that is in the uplink, and how also. Okay. Once the user equipment is able to decode this physical downlink control channel, then it will be knowing precisely where to receive or to transmit and how also. Right? As I said, the PDCCH is sent over the first 2 to 3 OFDM symbols of each subframe. Okay. As I repeat once again, one subframe will be having 2 time slots, that is 14 OFDM symbols, right? Each time slot will be having 7 OFDM symbols. Out of 14 OFDM symbols, so 2 to 3 OFDM symbols will be carrying information about what? Is it possible to say? Any one of you? Yes, my dear students. I am asking, is it possible to say what information the PDCCH will be carrying over the first 2 to 3 OFDM symbols of each subframe? Yes, any one of you? Then I can understand people are active and alert also. Hello? Yes, I feel nobody is responding. Why? Yes, am I audible? Hello, am I audible? I'm asking.
Yes, sir.
Yeah, if that is the case, if you are active, may I know what I asked? What is the question I asked? Can you repeat, Vishnu?
So you asked some 2 points, no, sir.
Oh, what is that? Hmm? Yes, others. What about others? At least he's responding yes or no. What about others?
Yes, sir.
Yeah, can you say what I have asked?
Sir, you asked what two to three OFDM symbols, so what it will be information it will carry.
Very good, very good. Means you are with me. Fine. So I was asking, means first I said what is the information carried over the PDCCH channel, that is a physical downlink control channel, right? I said the PDCCH will be sent over the first 2 to 3 OFDM symbols of each subframe across all the subcarriers. So I think other students, is it possible to say what information PDCCH will be carrying out? Yes, I think still slide is visible, right? The slide is not visible, the previous slide. So I said the PDCCH, that is physical downlink control channel, will be carrying information about what? Downlink.
Downlink.
Yeah, downlink resource block allocation, uplink resource block allocation, QAM constellation to use per resource block. Similarly, the type and rate of coding to use per resource block. So this 4 information will be there in PDCCH. Okay, downlink resource block, uplink resource block, QAM constellation, and as well as type and rate of coding to use per resource block. Okay, so see, if you concentrate and if you are attentive, then if you understand this, further slides becomes easy. So when you are not able to say what PDCCH channel will be carrying, then you will be again in dilemma only. Okay, I very clearly told you all will be wondering or maybe thinking how your mobile station will know that which resource block or what frequencies to be used for transmission and as well as reception. I said that will be known by what the base station will be transmitting that particular information to the user equipment over the PDCCH channel, that is physical downlink control channel. So what PDCCH will carry? It will be carrying the downlink resource block information, uplink resource block information, QAM constellation, size per resource block, as well as the type and rate of the coding. Okay, so if I say type and rate of the coding, you should all be able to visualize whether it is 1 by 3 or 2 by 3, whether it is a convolutional code or Viterbi code, like that, right? So different codes we know what type of codes are used in LT also. I've discussed it, right? Fine. I said the PDCCH, right, will be sent over first 2 to 3 OFDM symbols of each subframe across all the subcarriers. So hope you are understanding this point. 2 to 3 OFDM symbols. So one subframe will be having 14 OFDM symbols. Out of 14 OFDM symbols, 2 to 3 OFDM symbols will be carrying information about what? About downlink resource block, uplink resource block, QAM constellation size, and type and rate of the code. Okay. Yes, hope that point is clear.
Yes, sir.
Yeah. Then each allocation, what I'm saying, consists of what the resource block subframe. So as I already said, one physical resource block, that is PRB, will be equal to having 168. Okay, 168 resource elements. I said, right? That is 12 into 14 waveform symbols. Okay, fine. So the first 2 to 3 symbols in each subframe, I said, is used by the PDCCH. So it costs around 14 to 21% of the total downlink capacity is used by the PDCCH. Okay, so out of 168, if I say, it will be of that percent. And the additional downlink capacity is also used by other control channels and the pilot symbols. So let us see what are other control channels are there and pilot symbols are there, and for what purpose those control channels are used in the subsequent lectures. Fine. So the base station, to aid the base station in uplink scheduling, so LTE units utilize the buffer status reporting. So that is BSR. Okay. To aid the base station in uplink scheduling, LTE units utilize buffer status reporting. This is known as what? BSR, we say. Fine. Wherein each user can notify the base station about its queue length, channel quality information, feedback. Yes, are you able to get my point? What I said? To aid the base station in uplink scheduling means what? To inform the base station about the uplink scheduling, the LTE, okay, utilize what? Buffer status reporting. Okay, this that is known as, in short, BSR, we say. So each user can notify the base station about what? Its queue length and the channel quality information. In short, we say it is CQI feedback. Okay, so your mobile station will be intimating the base station, okay, about its queue length and as well as the channel quality information to the base station by using this. What is that? BSR reporting, what we say. Fine. So once the base station is well informed about the channels to or from the users and their respective queue lengths, okay, so it can more appropriately determine the optimum allocation among the various users. Okay, once the base station knows about what channels, okay, the user and their respective queue length, then it can decide about that. So in the downlink, the base station has the inherent knowledge of the amount of buffer data, okay, for each user. So while in the uplink, it can estimate the channel from each user, right? So the BSR feedback, what I said, what is that BSR? That is buffer status register, right? Buffer status reporting. So that buffer status reporting feedback is only used for uplink scheduling. And another one I said, that is channel quality indication, right? CQI. That feedback is only used for downlink scheduling and as well as for AMC mode selection. Okay, so two things are there here. When do we use BSR and when do we use CQI feedback? So BSR feedback is only used for what? Uplink scheduling, and CQI feedback is only used for downlink scheduling and AMC mode selection. So this CQI, that is a channel quality indicator, I said now, that reporting can be either periodic or aperiodic. So let us see in detail later on. If it is a periodic, at what frequency it will be giving the feedback to the base station, right? And if it is aperiodic, at what rate it will be. It may be wideband or subband, and even multiple CQI feedback modes are also defined for different scenarios. Okay, so hope at least you have got some idea now how BS and MS will be communicating and how do they know, means how the mobile unit or user equipment will be knowing what resource block to be used for transmission and as well as for reception, right? So with this understanding, and there is another topic called power control. It is also an important. So let me come back to this later on. Okay, how means especially this power control is done for mitigating the uh, intercell and as well as intracell interference. Okay, so by varying the amount of power to be transmitted from user equipment to the base station based on their location, we will be able to minimize the interference. Okay, so I will come back to that. So I think I am fine with this module 2, and one more topic is there, that is all about MIMO. So I am skipping that topic at present. I will come back to that maybe if time permits. Okay, so with this, whatever the topics I have covered so far, you will be able to answer more than one question in module 2. Okay, because entire so let me go to the next module, that is module 3. And module 3, already I discussed about the LTE architecture, right? And what are its design specifications and thing. Just let me have again a recap of that. So I discussed the architecture of LTE in detail in the beginning only, right? So I hope you all should be able to recall that with the video also I have shown with real time analogy. Okay, is that fine? Yes, looking at this diagram, any one of you can comment. What is this? Yes, my dear students, is it possible to comment? Anyhow, I think yes. Hope you are able to recall. Yeah, this is an yeah. Yeah, what I wanted to say is maybe I have shown this not maybe in the same manner, maybe in a different way, right? So two things are there here. What is the first one? Is it possible to say what is the first diagram and what is the second diagram? Two network architectures have been shown. One is Utron and another one is E-Utron. I hope you are knowing what is Utron and what is E-Utron. So Utron means it is UMTS, terrestrial radio access network. Okay, U stands for what I said, UMTS. UMTS, terrestrial radio access network. And E-Utron stands for evolved UMTS, terrestrial radio access network. Okay, evolved UMTS, terrestrial radio access network. So what is the difference you are finding between these two diagrams? I expect you people to answer, because I spent more time on this architecture at the beginning to say about a flat network architecture and all, right? Yeah, in the first module only. Maybe the way I represented the diagram is different, that's all. Yes, is it possible to say something about this? What is there in the first one? What is there in second one? Any idea? Yes, anybody is ready to speak, or you don't want to speak? At least say yes or no. If nobody can say anything, I can proceed further.
So there is no RNC in the second network.
So you mean to say what?
So the job of RNC is taken care by E node B.
Very good, very good. Right. So in the evolved UMTS terrestrial radio access network, in short, what we say E-Utron, the number of elements, okay, the number of network elements in the radio access network has been reduced, okay, compared to the earlier version of the network, that is in Utron, that is UMTS terrestrial radio access network. in an radio access network, right, there are two elements. One is radio network controller, that is RNC, that will be controlling the nodes, right, base stations, what we call as base stations, node B, node B, right. Here, the functionality of the RNC has been brought into the node B, and we call that as E node B. Okay, E node B. So with that, compared to Utron, here the number of network elements has been reduced. So when the number of network elements have been reduced, so what happens? The latency will become less. Right here, the information has to pass through different nodes. Right, when the number of nodes are more, then at each node it takes time to process it. Right, so that has been removed by clubbing the functionality of RNC into the node B, and that is why it is called E node B. Okay, so with that, it is possible to achieve the low latency in case of LTE. Okay, so the core network, you all know what the core network will be having, and this is what the radio access network, and this one is the user equipment. And what usually we say, the radio interface will be from user equipment to base station. Okay, the term base station is used in 2G standard. Okay, and in 3G also, but in higher standards, that is in 4G, we call that as E node B in Utron, and E node B in the LTE. Okay, so with this basic understanding how the network evolution happened, okay, from I think again I need not go back from 2G, then 3G, then 4G. I think with respect to this diagram, you'll be able to understand that. Go back and have a look if you want the slides of module 1. Fine, so let me just have a discussion about the design principles or specifications of this LTE. Even that also I have discussed about the specification of LTE. So just let me say, uh, actually this LTE network has been designed primarily for high-speed data services. Okay, the other versions of the network like 2G is aimed for only voice, then some amount of data. In 3G, still it has voice plus little bit more of data compared to 2G. But this 4G, that is LTE network, is mainly aimed for high-speed data rate services. Okay, is primarily designed for high-speed data services. Okay, that is why we call this LTE is known as the packet switched network. Okay, from end to end, and it has no support for the circuit switched services. I hope you all understand what you mean by circuit switching and what you mean by packet switching. Okay, so basically LTE is a packet switch network, and because of that, so the low latency in LTE is achieved because of flat network architecture. Okay, with a reduced number of network elements, and it is possible to have the sophisticated quality of service architecture that has allowed the network to emulate the circuit switched connection. Okay, on top of this packet switch network or framework. So just let me say what are the specifications of LTE. Okay, so it is a completely means see 3G has been upgraded from 2G, but this LTE is not like that. It is a complete new design. What we say, it's a clean slate design. What we say. Okay, it is fully the packet switched network, which is designed for high data rate services. Okay, so what I wanted to say here, what are the specifications? Okay, uh, that 3GPP, that is third generation public project partnership. What we say, 3GPP is one organization where they are defining what should be the design specifications of the telecom networks. So they have decided and said the specifications. Fine. So in that, I think some few parameters. What I wanted to say is, first one is about the network architecture. Okay. So to say about the network architecture, here I said basically the LTE was designed to support the packet switched traffic, right? with various quality of service classes. Okay, and here this already I said how the network elements have been reduced, right? So in LTE radio access network, the E-Utron, okay, I said already what is this E-Utron? That is evolved UMTS terrestrial radio access network was designed to have the minimum number of interfaces. That is with the minimum number of network elements. Okay, and with that, with the minimum number of network elements, it is possible to provide an efficient packet switch transport for traffic belonging to all the quality of service classes like conversational, streaming, real time, non real time, and etc. So that is about the network architecture. First point. The second thing is about the data rate and the latency. Okay, so the targeted the design specifications at 20 megahertz bandwidth. Okay, the downlink data rate is supposed to be 100 Mbps, and the uplink data rate is supposed to be 50 Mbps. So if the network is possible to provide a data rate of 100 Mbps in the downlink and 50 Mbps in the uplink, so that is the target what that has been decided to design for this LT. Okay, so hope this point is clear. This is at 20 megahertz, 100 Mbps and 50 Mbps. 100 Mbps in the downlink and 50 Mbps in the uplink is the data rate target at 20 megahertz bandwidth. As I said, this LTE supports different bandwidths, right? So for different bandwidths, the data rate will be changing. Fine. I told about what is the data rate target. Then latency. I hope you all know what is latency, right? Anyone know if is it possible to say what is latency? Yes, my dear students, is it possible to say from your end what you mean by latency? Yes, no one. No one can say what is latency. Hello.
Sir, it is time taken for the data to reach destination.
Yeah, very good. Right. So when it comes to latency, we talk with respect to two things. One is the user plane latency, and another one is control plane latency. Okay. So user plane latency means it is the user data, okay, to be transmitted, means the time taken by the uh, user data to pass, means what is the smallest IP packet, okay, what is the time it takes to transmit the small IP packet from user equipment to the edge node of the radio access network, or even it may be vice versa also, right? So that is known as the user plane latency. Okay, I repeat once again, it is the what time taken to transmit a small IP packet from the user equipment to the edge node of the radio access network, or it may be vice versa. That is from radio access network to your user equipment. So how much time it takes to transmit a small IP packet, that is known as the user plane latency. So it is decided that for LTE, the one-way latency is of 5 milliseconds. Okay, this 5 milliseconds at unloaded network. So what do you mean by unloaded network is if only one single user equipment is there in the cell, then we call that as a unloaded network. So if more number of users are there in the network, then we say it is a fully loaded network. Okay, only if only one single user is there in one particular cell, during that time, what is the amount of time taken to transmit a small IP packet from user equipment to the edge node, that is known as the user plane latency. I said it is of 5 milliseconds for one way. Similar to that, there is another one. I said control plane latency. So it is what control plane latency is about is the transition time from camped state to an active state. Okay, so which is to be less than 100 milliseconds. And another state is there. One is I said the camped state to an active state. Another one is the transition between the dormant state and an active state. Okay, so that is should be less than 50 milliseconds. So these are the targets of control plane latency. One is 100 millisecond and another one is 50 milliseconds. But for user plane latency, it is of 5 milliseconds for one way. So two way, it will be 10 milliseconds. Okay. So the second thing I told about data rate and latency. The third one is the third parameter or the third design specification is about the performance requirements. Means under performance requirements, various parameters are there. In that, the first one is the spectrum efficiency. Okay. So to discuss with respect to the spectrum efficiency, what I can say, the average downlink user data rate and the spectrum efficiency. Okay, average downlink user data rate and spectrum efficiency is targeted up to 3 to 4 times more than the earlier network. So earlier network is what? High speed downlink packet access network. Okay, so whatever the data rate was provided by this HSDPA network, okay, it should be 3 to 4 times that for this LTE. Similarly, the average uplink user data rate and spectrum efficiency target is 2 to 3 times that of the high-speed uplink packet access network. Okay, means if it is uh, 25 Mbps, then 2 to 3 times. 2 times means 50 Mbps. That is why they said it is 50 Mbps for LTE. Okay, so it is 3 to 4 times. Means 100 Mbps stored in the LTE, right? So it may be around uh, maybe 25 Mbps in the downlink, right? So 25 4 is 100, maximum 100, right? In that sense. And cell edge throughput, so which is measured with fifth percentile throughput, what we say, it will be of around 2 to 3 times that of the earlier network, that is HSDP and HSUPA network. So that is about the spectrum efficiency. And the next performance parameter is what? Mobility. Okay, so it should be able to provide whatever the performance I said, no, that the data rate and spectrum efficiency, even when the user equipment means that when the user is moving at a speed of 15 kilometer per hour. Okay, 0 to 15 kilometer per hour. At that speed, if he is moving during that time, he should be able to get the maximum performance. Okay, maximum performance is what? That is downlink speed of 100 Mbps, uplink speed of 50 Mbps, other things, right? And with a slight degradation in the performance when the user is moving at high speed, that is up to 120 km per hour. Okay, when the user is moving at 120 km per hour, with a slight degradation in its performance, you should be able to access the network. That is mobility. The next one is coverage, we say. Coverage is of around up to 5 kilometers is made. Okay, the target is made up to 5 kilometer, and with a slight degradation, it can extend up to 30 kilometer. Okay, that is the thing. And another one is multimedia broadcast and multicast service. Okay, that is MBMS we say. Okay, multimedia broadcast and multicast service also be provided by this LT. Okay, so these are all things comes under the performance requirements. Okay, one is spectral efficiency, second one is mobility, third one is coverage, and fourth one is multimedia broadcast and multicast service. Okay, I think as of now I told about three things. One is about network architecture, second one is about data rate and latency, third one is about the performance requirements. Under performance requirements, I told about 4 parameters. That is, one is about spectrum efficiency, second one is about mobility, third one is about coverage, and fourth one is about MBMS service. And the next parameter is about radio resource management, that we say RRM. Okay, so radio resource management is one of the important and vast topic. What I can say means it is very important how we utilize the resources. Radio resource is here time, frequency, and power. So how do we utilize those three resources as efficiently as possible is a big challenge, right? So RRM requirements, what they said is here, it has to support the enhanced support for end-to-end quality of service. Okay, so with an efficient support for transmission of higher layers and support for load sharing, balancing, and policy management, etc. So we'll have a discussion about this. There is a one particular topic on radio resource management in this module only. I think you will be able to understand during that time what is the RRM target has been decided in the LT. Okay, the next one is about the deployment scenario and coexistence with the 3G. Okay, so here, uh, as I said already, from 2G to 3G, the network has been evolved, right? So this 4G, as I said, is a clean state design, which has been designed separately as a new protocol, and how it can exist with the existing network, right? So in that means whether it can be a standalone deployment or integrated with the existing earlier networks. Okay, so we'll see that what is that one means with respect to standalone deployment. What I can say is when the operators deploy this LTE either with no previous network deployed in the area or with no requirement for interworking with the existing Utron or other networks. I think I hope we will be able to understand how the Geo has entered, right? Because they were not having any 2G or 3G network, so directly they have deployed 4G. So they have integrated and other things, right? Fine. I think let me take the next one is about the flexibility. I think I said here uh, there is a flexibility of spectrum usage that is from 1.4 megahertz to 20 megahertz, right? So with respect to that, it can accommodate or provide a different data rates, right? That is 1.4 megahertz, 3 megahertz, 5 megahertz, 10 megahertz, 15, and 20 megahertz. So these are the different bandwidths it, it can support. That is what we say the flexibility of spectrum deployment. Then interoperability with the other versions of the network, that is 3G and 2G. Okay. I think even if I say something, you may not be able to get that point. Let me skip this as of now. Just let me have a look about this network. Hope is it visible? Able to read anything? Yes, my dear students, are you able to read what I am showing?
Yes, sir.
Yeah, is all already I've explained this architecture in a very different manner, and I hope you have understood. I don't want to spend much time again on this because already I discussed a lot about this, right? Just to have a recap, is it possible to say from your end? Yes, you have already studied for first internal, right? And you know what is this. I think many have not read, I think, architecture, what I observed from your answers. That is what I'm worrying. See, people should read the basic things properly. Because very few students I noticed that they are not even very few. One or two students only have attempted this network architecture. I think people have not given time to read and understand this architecture. Yes, hope able to see. Yes, I feel at least I think I can talk to 10 people with respect to this diagram. Each one of you, is it possible to read? Whoever is there, so far whoever has not spoken anything, I think around 25 people are there. Yes, out of 25, at least 10 people will get an opportunity to say what is the network elements. Those who have not spoken so far, I expect those to speak. I hope you all understand. Those who are talking to me, in every class, those who are not at all opening up their mouth. Yes, be fast. Don't waste time. Another 10 minutes I have. I would like to say this.
Packet
Yes,
data network, PCRF,
Akshata.
PDNGW.
One element you should tell, not all.
Okay, sir.
That is why
Packet
I
data
wanted,
network.
yeah, I wanted to speak to other people also. No. Hmm? Yeah, you are saying about what? You are saying about PDN gateway.
No, sir. Packet
Akshata?
data network. Yes, sir. Packet data network.
Packet data network is nothing but PDN gateway only. Okay. Okay. So hope you know, at least is it possible to say any one function of PDN gateway? Akshata?
Yes, sir.
Yes. Ah, yes, quickly. So similarly, I will be asking other students to say just one or two functions because I don't want to go again in depth because I said already I have spent enough time in conveying or discussing about the architecture of LTE. Yes, and I said no, even after spending so much of time, uh, I did not get answers for this in the test. People have opted different question. Yes, of course, you need to understand this architecture. Yes, quickly, Akshata. Akshata, is it
Yes,
possible
sir.
to say? Hmm.
Yes, sir. So it acts as an interface between the LTE network and packet data networks.
Hmm. LTE network and packet data network.
And other data networks, sir.
Very nice. Okay, it is
So
an
like between the
interface.
user equipment and the LTE network.
PDN I'm asking. Hmm. Yes, please have a look. Okay, okay, at least. See, I might have told it is just P gateway. P hyphen GW I might have written earlier. Okay. And while saying, I used to say it is a PDN gateway. So it is clearly written PDN gateway. So it is responsible for what? Allocating the IP addresses. What is this? I have taken with example, right? From Bengaluru to Belagavi. You and your friends wants to move from Bengaluru to Belagavi on the road. I started, no, I wanted to browse the network and you're looking for the network. So what you are going to do, right? What is that with explaining all that stuff? Still, people are not able to say. Hmm? So this PDN gateway is responsible for allocating IP addresses to the user equipment. Okay, then what's S gateway will do? Serving gateway. Yes, other student Akshata has told something, and Vishnu also added something to that. Other students, those who have not talked anything so far. Yes, come on. I think Saujanya Chaitra is not at all talking anything, has become fully silent. So if no active participation, it won't give any meaning. Yes,
Sir,
what Chaitra?
for forwarding the data packets, for routing and forwarding, serving
Yeah, serving gateway will be doing the routing and forwarding the data
data
packets to the user equipment. Okay. Yes, next element.
HSS is a central DB. Uh, it provides
What
the
ma?
user HSS.
HSS. Okay, HSS. Yeah, it is there. Fine. So
It provides the
HSS
user
will.
authentication.
Okay, it provides the user authentication. Fine, I understand. Yes, then yes, other people. Yes, Keshav, Kanya, Keshav, Venkatesh. Yes, Keshav, Venkatesh.
Yes, sir.
What is, man? You say something, no, about I'm asking about the network elements. One of your friends said about PDN gateway, then serving gateway, then about HSS. Other one of your student has told friend. Can you just say one function of another network element? Can you say about MME?
So for this TNGW, it acts as the interface between this LT network and other data packet networks.
Can you tell the functionality of MME?
MME. Yes, sir.
What can it at least tell the expansion of MME?
Sir,
Hmm. So we're searching in
mobility
Google.
management entity, sir.
Okay. What it does?
Sir, it is actually used for, it presents as a key control node for the LTE access network, sir.
Hmm. Yes. What about Ashwin? Ashwin. Not talking only. Ashwin. Yes. What about Siri?
Yes, sir.
Yeah. I'm giving you a choice. You tell any one element functionality.
Sir, PCRF, sir, it is a software node that is used to determine the policies of the network, no, sir.
Yeah.
That
Good.
is, PCRF is nothing but policy and charging rule function.
Okay. Very good. Then anything else? What is left out? PCRF is told. HSS.
SGSN, sir.
Yeah. SGSN. What is that, Lavanya?
Serving GPRS support node.
Serving GPRS support node. Very good. So is it part of LTE network or is it other versions of the network?
LTE network.
No, sorry. So you just see that why they have marked oval shape. No. So whatever is
Yes,
there
sir.
in that oval shape, that is EPC, what we say, that is Evolved Packet Core Network. So in Evolved Packet Core Network, P gateway, S gateway, and MME are the three network elements. This SGSN belongs to 2G and 3G networks. That is why, see, this Geron and Utron are connected through this SGSN. Okay, it does not come under
Yes, sir.
LTE. That is why it is written outside the network of this EPC. Fine.
Okay, sir.
Yeah, one is EPC, another one is E-Utron, what we
Yes.
say. So together is known as the EPS system. Then
Okay,
user
sir.
equipment will be there. So that is all about the LTE. Yes, next Vandana.
Yes,
Okay,
sir.
fine. Yeah, just can you say anything about this, any of these network elements, whatever is shown here?
E node B, sir.
Yeah, what is its function, E node B?
It helps in ciphering packet reliable delivery and header compression.
Okay, it helps in ciphering.
Packet
Repeat
reliable
once.
delivery and header compression, sir.
Okay,
And it also functions as radio source management.
radio resource management.
Yes.
Fine. So I expect you all people to just have a look. I think the first module I went depth, okay, about the architecture. So again, I don't want to say spend much time on that. So I will be talking next about the layered architecture. Okay. So far whatever is done all basics like all multiple access techniques and other things what we have discussed. That is understanding. Now I will go about the layer by layer architecture, right? So what is the function of each layer? So definitely, if your CCN understanding will help you a lot to apply your knowledge here. How there the protocols works and how it is different here. Okay, and in what way they are similar. Fine. So I think with this, let me stop today. So I will be talking about the layered architecture and functionality of each layer with respect to LTE.